So it was with this background that we started to develop a technique that we could use for objective lameness evaluation in horses. Initially, mostly for the purposes of using it in clinical studies, but also for standardizing teaching of lameness detection to veterinary students. We started in 1993. Our goal was to develop an objective method of lameness evaluation in horses. Based on opinions and evidence from leaders and other professionals who are interested in the fields of lameness and biomechanics in horses, we concentrated our development on kinematics, or on using kinematics, which is studying movement, rather than on kinetics, which is limited to the study of ground reaction forces. Studying kinetics may seem at first like the most direct and applicable technique, but many factors, mostly concerned with technology development, ease of use, and also the more intuitive basis of kinematics, caused us to concentrate at this early date on kinematics. But early on, we really did not know what to measure, or we didn't know what measure or combination of measures, movement measures, best detected lameness in horses. If you're familiar with the literature, both in the human and veterinary fields, on using kinematic gait analysis for the purpose of detecting musculoskeletal abnormality or lameness, you'd soon realize that there are a potentially unlimited number of movement parameters that one could measure, including but not limited to movements of the torso, stride length, stride rate, joint angle changes, abduction and adduction of the limbs, etc. And in fact, many studies, early studies, did just this. They measured many different things, usually on few numbers of horses, hoping to find one or two in their study that were associated with lameness. So at this early stage, since we didn't know what to measure, we collaborated with computer engineers. Computer engineers are very good at sifting through lots and lots of data to find patterns. We went to them with our purpose, which was to develop an objective method of lameness evaluation, and with our resources, we had an equine treadmill, high-speed cameras, and a state-of-the-art computerized kinematic gait analysis system. Well, they looked at our purpose and our resources, and they quickly identified that this was a data mining problem. So they instructed us simply to go back to the laboratory and to collect sufficient data from horses that we knew, or at least we thought we knew, were sound, and from horses that we thought were lame. So we did. We went back to the laboratory and collected data from horses that we thought were sound, from horses that we thought were lame, from horses with natural lameness, and from horses in which we induced lameness in using various models, including sole pressure, injection of collagenase into areas like the check ligament, interleukin and endotoxin injection into joints, etc. So we collected this data using this technique by putting markers all over the horse's body in order to encompass as many movement parameters as possible, using the treadmill, high-speed cameras, and our state-of-the-art kinematic motion analysis system over about 5 years in hundreds of horses. We then handed this data over to the computer engineers. They used a combination of data mining algorithms, which included a wavelet analysis technique that, as a simplified explanation, basically measures the overall shape of the signal, incorporating as many different qualities as possible in the movement signal. They fed the coefficients of this shape analysis into a neural network classifier, which is a machine learning technique modeled on the structure and function of the human brain, along with the prior known states, which we supplied to them, lame in the left, sound, lame in the right, and search for the best combinations using the least number of body movement signals that gave the best differentiation of sound from lame and lame left from lame right. What they found was that vertical motion of the torso gave the highest correct classification of lame from sound and lame left from lame right, with the least number of markers than other movement signals. So vertical motion of the torso, more specifically vertical motion of the head and pelvis, gave better differentiation of sound from lame and lame left from lame right than other combinations of movement signals, which included movement of the limbs in the horizontal and transverse direction and also specific joint movements. This does not mean that measures like stride length or stride rate or joint angle measurements are not good, at least in some lameness conditions, at detecting lameness. It just means that they're not as sensitive as vertical motion of the torso as picking up the general lameness condition.